As a static equipment manufacturer, designer, or draftsman, you can save up to 80% from your time and money. SEG has helped reduce man-hours and costs. No software anymore to generate 3D models and workshop drawings. It is a matter of minutes. SEG Software makes modeling and detailing of the static equipment much easier, faster, and accurate. You can decrease your working load and increase your efficiency, quality, and ability to engage in more projects in the same time. We care about your requirements and need. Software made by engineers for engineers. SE CAD Solutions offers advanced tool for the accurate and speedy production of 3D digital prototype and workshop drawings deliverables of pressure vessels, towers, storage tanks with fixed roof, heat exchangers, spherical tanks, ducts, slug catchers, and equipment piping. The only existing software can do all of this stuff under one umbrella. Link to Integraph PV Elite software exported access file, compressed software exported XML file, and HTRI software exported CSV file. SEG delivers significant savings over existing 3D CAD modeling and drafting methods. SEG working over Autodesk Inventor as a platform, and soon, SEG will be available on SolidWorks platform. SEG aids you to generate a 3D digital prototype for your equipment prior manufacturing process and creation of workshop drawings. Easy to get a detailed bill of material, nozzle table, welding details, and more. SEG supports a wide range of equipment designs and configurations. Horizontal, tilted, and vertical vessels. Various supports including saddle skirt, lug, legs, and more are provided. Columns with multi-sectional shells with different diameters and transitional sections. Vessels with half-pipe jackets and coil on shells. Tema heat exchangers and a special tool for tube bundle holing and assembly. A special tool for roof and bottom plates arrangement. Different types of roofs are supported, like radial, arranged plates, and dome roof. SEG supports a wide range of appurtenance features and configurations. Internal, external components are included. More than 30 types of nozzles, cleanout doors, couplings, stud outlet, weld-a-lit, and thread-a-lit. More than 12 types of lifting lugs and trunnions. SEG can be mastered in 1 day of training. SE CAD Solutions, beyond limits.
Using SEG software, you will save up to 80% from your time and money. Here in this graph, we make a real comparison for this project by using 3 different ways. The first way was by using AutoCAD. The second way by using a pure CAD software like SolidWorks and Autodesk Inventor. The third way by using SEG software plus Autodesk Inventor. For the first case, by using AutoCAD only, we consumed around 50 hours to generate the fabrication drawings for this equipment, for the GA and bill of material, and the other details like manways, saddle detail, nozzle detail, all of that. By using pure CAD software like SolidWorks or Autodesk Inventor, we consumed around 24 hours to generate the 3D model and around 10 hours to generate the fabrication drawings. The total consumed hours are around 35 hours to generate both of them. By using SEG software for the same case, we consumed around 5 hours, between 4 and 5 hours to generate the 3D model of the equipment, and consumed 2 hours to generate the fabrication drawings for the same equipment. So you can compare between total 8 hours by using SE software and 50 hours for the same by using AutoCAD. So you can imagine how much time and money you will save in case of using SEG software. SEG software is the only existing software can cover all of those types of equipment like horizontal and vertical vessels, columns with multi-sectional sections and different diameters, storage tanks with fixed roof, TEMA heat exchanger, equipment piping, slug catcher, ducts, and finally spherical tanks. SEG, we have 2 types of licenses. The first type is the hard key license. In this case, you will need a USB stick this USB stick will be your license. So that means you can move it from machine to another, because the license is the USB stick itself. So you can move it from machine to another. The second type of license is the internet license. In this case, the user should be connected to the internet to be able to run SEG software, and we have many different options in this type of internet license. By using SEG software, you will be able to generate different type of equipment. And today, inshallah, we will discuss the storage tanks with fixed roof. And those are some real samples for equipments generated by SEG software, pressure vessels and heat exchangers. Before dealing with the SEG project, we have different levels to define the project. The first level on SEG 3 is the project level, which includes the project information like project number, project name, location, client, all of that. And those information shall appear on the title block of your drawings. The second level is the equipment level. In this level, you can define the equipment design data like pressure, temperature, maximum allowable working pressure, the wind code, seismic code, all of that you can define it for the equipment itself. In the same node, which is the equipment level, we need to define some options for the equipment itself, like the position of the equipment, if it's a horizontal or a vertical vessel, or tilted vessel. The assembly direction of the assembly, if you would like to start your assembly from bottom to top or from top to bottom. If in case of horizontal vessels, you can make the assembly start from left to right direction, or reverse it to be from the right to left direction. In the same form, you will need to define the units of the units used in your equipment for dimensions, like if you would like to make it millimeter or make it in inches. And you will need to define the raw plate dimensions, which is the delivered plate dimensions that will be used in fabrication, because SEG will use it to calculate the plate arrangement in roof and bottom and shell plates. By using SEG software, you will be able to generate all parts, assemblies, and bill of material automatically, make a nozzle opening sheet metal flat pattern, make a 3D modeling, export your 3D model and 2D drawings to many different extensions like DWG, DXF, DWF, and more. You can generate a material cost report for your equipment to make an estimation price for the required material for your equipment. For the storage tanks, you will be able to generate radial roofs, ranged plate roof, zoom roof, bottom plate, and annular plate. You will be able to add some attachment to this storage tank, like spiral stairs, clean outdoors, and manways. And both of clean outdoors and manways are related to the API standard. And if you would like to make some modifications on it by hand, by changing the dimension, you will get a chance to do that by selecting an option to define the dimension manually. As discussed, by using the storage tank module, you will be able to add annular plates, bottom plates, compression ring, roof plates, anchor chairs, and many different attachments to the storage tank. Regarding the annular plates, for example, we have three different types of annular plates. The first type, which is equal annular plates. If you would like to make a certain number for the annular plates, and SEG will calculate automatically the dimensions of each one because they are symmetric, so SEG will deal with that. And if you would like to define each blade arc length, so SEG give you the ability to do that. The third type, by control the thickness for each plate. If we take a look to the sample of today here, if we take a look to the bottom here, you can figure that the thickness of this annular plate is different from the other one. So make it like that. So you can figure that the thickness of the annular plate here is different from that one. That means this type of annular plate, which is the third type, which is annular plates from different pieces and thicknesses. You will be able to generate different types of bottom plates, like bottom sloped to inside, so the highest point will be on the middle. Sloped to inside, so the lowest point will be on the middle, like that. Sloped bottom from one side, the bottom will be sloped in one direction only, and the flat bottom. Different type of shell plates are included in SEG, and the most common types for storage tanks, we usually use three different types. The first type is shell different from different pieces. In this case, you will be able to control each piece arc length. The second type gives you the ability to control the thickness of each plate. If we take a look to the same model here, you can figure that for the shell plate here, this shell thickness on the same shell course, you will find that this plate, if we open it in a separate file and take a look here, you can figure that the shell thickness here is different from the other plates, and the SEG will give it another color, or darker color, to make you able to know that this plate is with a different thickness from the main shell course plate. Okay, that's the one of the most used types on shell types on SEG for storage tanks. If we come back to our presentation here, you can add a compression ring based on the API standard, like that, and select the suitable type for your case to add it. By using SEG, you will be able to add radial roofs, radial blades, and ranged blades, dome roof, and dome roof with radial blades. You will be able to add anchor chair and add some attachments to this anchor chair, like if you would like to make it with a weir plate, which is a reinforced bed, you will be able to make it like that. You can add, if they are identical, you can add them identical by defining the quantity of number of anchor chairs to make an equal arrangement for them. And if you would like to make some of those anchor chairs with different dimensions, SEG give you the ability to do that. Different types of clean outdoors and davits of the clean outdoors. You can select the suitable type for your case. You will be able to add spiral stairs to your equipment. The nozzles according to the API standard. You will just select the size of the nozzle and select the type of the rebad. If you would like to make it a circular rebad, diamond rebad, or low type rebad. Define the orientation, location, all of that. Here we will make, in this fast track video, we will make a roof plate for a tank with 42 meters diameter. Define the plate dimensions. We will make all of that in detail in our demonstration of today, inshallah. Here define the diameter of the roof. and from here make the plate arrangement. And by using SEG, you will be able to make some modifications like rotate the rows to make it vertical rows, merge some rows, and split plates like this. Define the width of each plate if you would like to change it to make it suits your requirements. After that, we will save those information to sending it to Disk Inventor to generate the 3D model and parts for this roof. Here you can figure that the assembly of plates is generated automatically. Each plate of those is a separate part, and the SEG created and create the bill of material of each element. Okay, by using SEG, you will be able to generate a sheet metal flat pattern for all plates, and you can use that to generate a nesting report or a nesting calculation by using the Autodesk nesting tool. Okay, as you can see, we make some nesting calculation for the annular plates and bottom and roof plates, plates for the anchor chair and rebads. Here we will make a nesting for the annular plates in this video by generating a new study. The nesting tool will detect the thicknesses and the material for each plate. And after this step, we will define the available plate dimensions. Okay, after that, we will start creating nesting study to calculate the required number of plates. Here the nesting study is done, and the efficiency of this nesting. Okay. We have some slides for heat exchanger, but our scope of today was for the storage tanks. Let's close this project first, and if we take a look for fast look for the other options, SEG can create heat exchanger by dealing with the HTRI software, and we have a special tool for the cube sheet hauling. By using this tool, you will be able to generate the tube sheet better. SEG deals with different types of TEMA heat exchangers, as mentioned here. There is a tool for the parametric modeling, so you can make a parametric condition between two parameters and link them with each other. So if you change one of them, it will be reflected to the other one automatically. You will be able to generate your bill of material and export it in Excel format. You will be able to generate an estimation material cost report by defining the price of each material per ton, and SEG will prepare a material cost report based on your prices. You can generate the sheet metal flat pattern and make hauling for nozzles automatically on shell and head plates. You will be able to export your 3D model in many different extensions, and here you have a list for the available extensions that you will be able to export to it. The same for drawings. In drawings, you will be able to generate the general arrangement drawing, sub-assembly drawings, detailed drawings for nozzles or supports or that. And you will be able to export some standard tables like the nozzle table, bill of material table, design data table, the notes, and many other tables. You will be able to export it. And you will be able to export the welding details. SEG includes a huge library of welding details. You can select the required welding details and export it to your drawing. And you can import your standard title block or standard drawing to SEG to use it anytime that you would like to generate a drawing. The integration tool with BV Elite software to generate the 3D model by reading the exported access database file from the BV Elite. SEG includes a huge number of nozzles types, like nozzles from pipes or plates, standard long weld neck nozzles like long weld neck ASME nozzles or BSEN nozzles, self-reinforcement nozzles, forged hubs, and forged hub with lips, and integral forged hub with lips, oval opening and rectangular opening, different type of support and different type of saddles, different type of lifting lugs, and here some of the common lifting lugs in SEG software, and lifting triangles. Okay, so let's come back to SEG software. And let's create a new project. From new, we will make a demo tank today, inshallah. And from here, we will select the location of the project. So that's the name of the project, the location of the project. And from here, we will select the suitable module for our case, which is the storage tank module, and click on finish to start generating the project files. And as we discuss here, from the left hand side, you will get the SEG tree, and from here, that's the level of the project. From the project level, you can define the project information like project number, name, plant name, client, location, manufacturer, all of that. The second level is the equipment level, and you can add more than one equipment in your project. From here, we will define the name of the equipment as that. Level, equipment name, and from the setting, if we open the equipment setting, you can figure that for the storage tanks, automatically it's defined to be a vertical position of the equipment, and the assembly will start from the bottom to top. From here, we will define the available plate that we will use it on fabrication, and select the used units, which is metric units per millimeter, and from here we will select save. From here we will start creating the first element, which is the annular plates. Okay, and if we select the annular plate, you can figure that we have three different types. The first type is equal annular plate. By defining the number of segments and the other dimensions, SEG automatically calculates the arc length for each plate. The second type, which is annular plate with different pieces, here you can define the each arc length for each plate. So from here you can define each arc plate length, And we will use the third type, which is the annular plate from different pieces and thicknesses. Okay, so we can control each blade thickness and each blade arc length. Okay, so let's define the annular blade outside diameter. If we open the paint, for example, if that's the shell inside diameter, and the inside diameter here, if we would like to make the inside diameter of this tank with that diameter, and here we have, we have this annular plate that, and the thickness of the shell is 14 millimeters, and we need to make the extended length here is 70 millimeters. So the outside diameter of the annular plate will be that plus 28 millimeters, so which is a double thickness, plus 140. So that will be the outside diameter of the annular plate. So if we come back to SEG, here we will define the outside diameter of the annular plate, define the thickness of the annular plate. Here we will define the edge length, so which is dimension W. If you take a look to the image on the right hand side, that's edge length. From here you can define the material. Here the bottom plate thickness, we will define it from here, and the number of segments here, we will make it 8 plates, and from here we will define the length of each plate to be like that. And let's click on generate the plates, and let's define each plate length. So let's define the thicknesses first here, and the second annular plate length. The other plates will be 12 millimeters thickness. Now we will define the length of each plate. The second plate we will make it 4 meters point. The other plates, make the other plates are equal. Let's calculate the number, so you can figure that the last one become the same because we make the other plates are the same. Now we will define the start angle of the first annular plate and click on calculate. So from this table you can figure that here for the first plate, that's the length of the arc length, the thickness, and the start angle for this plate. For example, the start angle from here, and the mid angle and the end angle of this plate. And you can figure that the second plate takes the start angle of the second plate takes the start angle of the previous plate, like that. Okay, now we will click on update grid, and before starting generating the elements, we will add another option here from the app setting, which is make a parent preview and a child preview. Those options give you the ability to make a rendering for elements during creation on Autodesk Inventor. So we will select them, and from here we will click on start to start generating the annular plates. So you can figure that each part generated automatically and assembled automatically. No need for the hand entrance. Okay, now we have the annular plates. Now let's add the bottom plates. And from here, let's add a flat bottom. From here, we will define the thickness as 8 millimeters, the overlap the bottom diameter, if we open this image again here, as we defined on the length of this plate, we defined it to be as a 1 meter. So it was 100, and the outside diameter that we defined in that case, the outside diameter of the annular plate was like that. So the inside diameter of the annular plate will be, so we will decrease 2 meters, 1 meter from each side, okay, and we will add the overlap, which is 50 millimeters from each side. So we will add 100 millimeters. So that will be the diameter of the bottom plate. So from here we will define the bottom plate diameter, and from here that's the value of the torch cut tolerance. Okay, by adding this value, SEG will automatically detect that the half plates will not be the half length of the plate, because we have a torch cut tolerance. But in this case, we will make it 0. Okay, and let's start generating the plate arrangement. Here from this form, you will find some initial options. Those options will give you the ability to make the suitable arrangement for the plates. For example, if we make a draw plates like that, you can figure that the welding line become on the middle of the circle. But if you would like to add a middle row, let's reset the grid, and from here let's select the mid row and click draw. Now you can figure that you get a mid row on the plate. What if you would like to reverse the arrangement? So let's reset the grid and reverse this arrangement. You can figure that we have 2 plates on the middle, and we flip the arrangement of the bezel. So let's make a reset and make all plates centered. So if we make a draw, you can figure that you get this arrangement of plates. But right now, if we would like to make a modification for this plate, for example, if you would like to make it offset or define the length of this plate, if you would like to make a half plate like that, so you have the ability to control the length of each plate separately. And we will discuss that again on the roof plates. So let's accept this arrangement right now like this, and click define the orientation, the longitudinal welding line orientation at 0, and click save. Now let's click start assembly to start generating the bottom plates as we defined. And you can figure that we have an overlap with 50 millimeters.
Hello.
Now let's add a shell sheets.
Sir.
So from the elements, we will select CAD.
Ahmed,
yes.
Just one doubt is there from Hyderabad. This your bottom plate you have shown, sir, overlap type, na? Hello.
Yes. Yes, complete. I'm here.
That bottom plate, instead of overlap, if you put some gap, and below that one steepener plate is also there sometimes. Butt joint. Can we make it that type of bottom plate also?
By defining the overlap value is 0. Yeah, you can define it to be 0.
And then below that one steepener plate is also there, sir. 50 mm steepener plate. 50 mm flat steepener plate. Instead of overlapping the plate, 50 mm steepener plates will be there.
Yes, you will make the overlap value with 0, so the edge will be to the front of the other edge. Okay.
Okay.
Okay, we will add shell course and click add. From here, you will find many different type of shell plates. You can make the shell as a pipe, or from plate without welding lines, or from plate with a welding line. But usually we are using, for storage tanks, we are using the shell from different pieces. This option will give you the ability to define each arc length of the plate and different pieces, and for the sloped bottom, if we have a sloped bottom from one side, so you can define the shell to be cut from one side like this, or shell from different pieces and thicknesses, this type. And in this case, we will define the dimensions of this can. So the inside diameter is 8 meters, 0.5. The height is 2 meters. The main course thickness is 14 millimeters, and the number of segments will be 4 pieces. Now let's make update for the grid. And from here we will define the each plate length. The first one will be 9 meters. The second one, we will define it to be like that. Let's define the thicknesses. So 14, 14, 14, 14. That's the thickness of each plate. And let's define the start angle of the first plate, and click on update. This value actually I calculated to make the mid angle here for this one looks like the angle here for this plate, because this annular plate we will add a shell blade course over it, so we will need to make the mid angle looks like the same here. If we click on simply,
लेंथ कैसे कैलकुलेट किया लेकिन ये लोगों ने?
Sorry, I define the height. Sorry, if we come back here, so we need to define it to be 2 meters.
ये length and total plate 9 meters.
Okay, now we have this can. We will add other cans to this storage tank. So from here, let's add another can, which is can 2. In this case, we will select another type, which is shell from different pieces. Okay, to control the length of each plate separately, and define the inside diameter, the height of the course, the thickness, and the required number of plates, the first plate length, and the orientation of the first longitudinal welding line. And let's click start. Okay, that's the second can. We can check the welding line orientations. If we find something, make a clash, we can rotate it. Right now, no clashes, so let's come back here and add another can. Can 3. And in this case, we will make it looks like can 2, because it's the same type. So we will select it here and define the thickness and change the longitudinal welding line orientation, and click start. Let's add one more can and the compression ring. After that, we will add the roof and the proceed with the attachments. From here, let's add a can 4, and let's make it looks like can 3. And from here, let's define the thickness to be 8 millimeters and the first angle for the first longitudinal welding line angle, and click save. Now let's add a compression ring. From here, let's select the first type and define the bend diameter. If we open that one here, at the top we have thickness as 8 millimeters. Okay, and we have the angle here. Like that. Okay, so the outside diameter of the shell, the outside diameter, if we draw this like that, if we would like to calculate the outside diameter of the shell, we have the inside diameter plus the double of the thickness. So the bend diameter here will be, so that will be the bend diameter. So we will open SEG and define the bend diameter. Select the size of the angle and click on save. Now let's define the roof plate. So from arranged roof, we will select arranged roof, on save, and from here let's define the those dimensions: the opening at the top, the thickness of the roof, let's make it 6 millimeters, the slope and the overlap, here the end diameter. So if we come back here again, and if we make the roof, make the roof like that. So the dimension in this case for the roof here, we will make this offset to make it 30 millimeters. Okay, so the outside diameter of the roof will be that value, which is the shell outside diameter, plus 60 millimeters, which is 30 millimeters from each side. So that will be the diameter of the roof, 9576, so 9576 here, and we will define the torch cut tolerance to be 0, and from here we will click on save, and let's generating the plate. So let's minimize the scale a little bit and click save, open again. Okay, here we will after defining this, we will start generating the plates. So let's add a mid row and check. Here we have this mid row, so let's reset this and make draw for plates like this. And we would like to make plates here on a vertical position, so we can make the orientation of this plate as a vertical plate. In this case, we can merge those vertical rows. From here, we can make this plate as a centered plate. Okay, and we can define the width of this one to be 2 meters. Redefine it, and we can make split for this plate. Define this one. 2 meters. Okay, and split here. Define this to be 2 meters. The same thing we will do it here. So we will make this plate as a vertical and that one as a vertical. In this case, we can merge those plates from here. After merging them, we will define this mid plate to be 2 meters and split here and there. Define the width of each plate to be 2 meters, like that. And from here, we will select this plate and make it a half plate, like that. And if you would like to define, if you take a look to the information here for this plate, the width of this plate will be 4 meters, 0.5. Okay, and that's the height of the cell. If you would like to define a certain value, like making it as 5 meters, you can control the width of the plate like that. But let's make it as a half plate and change the orientation to be at 0 and save that information. Now we will start creating the assembly for the last can, the compression ring, and the roof plates. So during the assembly, you can figure that how much time you will save in case of making each part of those by a manual way. But by making a sketch, generating a feature like extrude or revolve for this element, and assemble it with the visual assembly. Here SEG will deal with all of that by generating parts, assemblies, and drawing, as we will discuss inshallah. That's the roof plates as we defined. After that, we will add some attachments to this storage tank, like adding a cover for the roof, adding the clean outdoor. Here, let's add a clean outdoor to this area here for this piece. So from here, let's select can 1, and from elements from the nozzle parts, we will add a clean outdoor. And from here, when you select the clean outdoor, you can figure that you have many different type of davits. So you can select the suitable clean outdoor with the suitable davit for your case. Here we will select this type and define the size of the clean outdoor to be like that. And from here, we will define the shell over thickness. Because this clean outdoor laid on another plate with a different thickness, here as we said, we make the main thickness of this shell is 14 millimeters, but this plate is 18 millimeters. So we have 4 millimeters difference between both of those plates. So we will make the over thickness as 4 millimeters. Define the neck thickness to be the same of the shell thickness, which is that shell. Okay, so we will make it 18 millimeters. The cut clearance, the orientation, we should make the orientation to make it on the middle of the shell. So if we come back here, so that's the mid angle of the plate, okay, that we have, which is that one. So we will define the orientation of this plate as the same. Okay, and if you would like to define the dimensions by hand, you can click on user define dimensions to be able to define it by hand. Now that's the flange thickness, the cover thickness, and click on save. Now let's start simply the clean outdoor. The dimensions of the anchor, the annular, for the clean outdoor, based on the API standard. So those dimensions which they are disabled, those dimensions are getting from the API. In case of if you would like to make a change by hand, you can make it by defining the dimensions from this checkbox. Let's come back to the assembly. Now we have this clean outdoor on place. Now let's add the anchor chair. So from here, let's select the can one. And from elements, you can figure that you have many different type of the supports. We will select the required for our case, which is anchor chair. And from here, we will define the anchor chair dimensions, the projection, the edge, and from here we will define the orientation, the rib height, the projection at the bottom. As we defined here from this drawing, we make it 70 millimeters, the projection of the annular plate, so we will reflect that here. The rib thickness, and if you would like to add a wear plate, you can add it from this checkbox to add a wear plate. From here we will make 8 equal anchor chairs. So if we click on start, okay, now if we take a look to the location of the anchor chairs, those are the anchor chairs as we defined. Okay, no clashes. That's okay right now. Now let's add a sump nozzle. So from here, let's select can 1. And from here, we will select shell nozzle according to the API
Mr.
with
Ahmed,
internal projection. Yes.
Mr. Ahmed, sorry to interrupt you.
No.
Just a second. How much time more it will take? I guess it will be more than 1 hour still to deal with entire all the features of this tank fabrication.
I don't get your point.
No, how much more time is required to demonstrate all the features? That's my question actually.
Actually, I cannot demonstrate all features. You will need 5 or 6 hours. I will demonstrate some features which will give you the ability to know the capabilities of SEG.
No, I was just thinking, can we take a break now? Can we meet after 1 hour? Is it okay, or should we continue?
Actually, I have another meeting after 1 hour, so we could.
No problem. Murli?
Yes, sir. Let him continue, sir.
Okay, right.
Yeah.
No issue. Okay. Yeah, please, sir. Yeah, go ahead. Yeah.
Okay. Sorry for that, but I have another meeting, so if we
no issue.
If you would like, we could arrange for another day.
No. Let us continue. Let us continue.
Okay. Here we will add some nozzle. So from here we will select the can 1, and let's select a suitable nozzle for that, which is shell nozzle with the internal projection according to the API. So let's add N1. And from N1 here we will select 4 inches nozzle with the schedule 160, or let's make it 40. Okay, with the thickness 6.02. That's the standard thickness according to this schedule. The location, define the location and the orientation. The projection, we will define the external projection to be like that, and the internal projection to be 1 meter and 500. Okay, like that. And for the rebad, let's select diamond blade, and the thickness of this diamond blade, we will make it 14. Looks like the shell thickness. And let's click save. Now let's add an external flange to this one. So from here, N1 flange. And from here, let's select the suitable type for this flange and make it weld neck raised face according to SMA be 16.5. Select the size to be 4 inches, the same schedule, and click save. Now, if we come back to the nozzle, you can calculate the projection from the vessel center line. So if we make it like this, that's the outside diameter of the vessel at the bottom course. If we divide it like that, and if we would like to make the projection from the facing of the flange 200 millimeters, so we will add that value. So the projection that we need to the facing of the like that. I write it. Okay, so if we calculate that's the pipe projection, and to the facing of the flange it will be 200 millimeters. So if we click save like that and click simply, okay, now we have this sump nozzle. If we measure the projection of this nozzle from here to the tank center line, here you can figure that that's the value that we entered here on the SEG. Now let's add, if we take a section at the top view, let's take a section like that, for example. Okay, and let's add an elbow and another pipe here. So from here we will select the internal projection of the nozzle, and from here let's add an elbow. From here we will select long radius 90-degree elbow, select the size of the elbow, schedule, the same schedule, and click save. Let's add another pipe after this elbow. And for this pipe, we will define the size, schedule, and the length. Click save. Now let's start assembly. Okay, now we will need to add a sump to this bottom plate for this nozzle. So let's come back to SEG, and from here we will select the bottom, and let's add a sump. From here we will select the sump to be from plate, define the inside diameter, the thickness, longitudinal building line orientation, the offset, the orientation, the same orientation of the nozzle, the projection of this pipe, and make it sit in. And for the reband, let's add a reinforced band, the same thickness of the bottom and let's save this, and from here let's add an end plate, but let's first create this. After creating it, we will add an end plate for this sump. Now we have this sump, and we need to add an end plate here. So from here we will select the sump, and from elements we will add end plate. Select the suitable, which is circular plate without holes. Define the diameter of this plate, the thickness of this plate, and generate the assembly. Okay, if we configure that, we add an end plate here. Now let's remove the section, and let's add a cover for this roof. Add some nozzles. After that, proceeding with the spiral stairs and generating the 2D drawings, inshallah. Okay, so we will select the roof plate, and from here let's select a cover plate. From here, let's define the dimensions of this cover. The radial plate thickness, which is T1. The overlap, let's make it 50 millimeters. The length of this one, let's make it 20. The weld gap, the number of plates, let's make it 2. Let's add a cover plate, and let's click on save. Let's add a nozzle to this roof. Okay, from here we will select a nozzle from pipe. Let's make it 24 inches, for example, and let's make it with let's make it 20 with that thickness. The offset from if we take a look to here, if we would like to make it right here, so let's check 3 meters from here. So 3 meters from the center line, the orientation will be on the 0 degree, and let's add a repad. The repad width will be like that. The thickness will be the same thickness of the roof, and the projection, let's the projection of the facing of this pipe from here, from the weld line, let's make it 1 meter. Check it first. After that, we will update it. Required. Here, that's the cover plate. Okay, we have now this Manway. We could increase the offset a little bit and minimize the projection. So if we come back to the nozzle again and define the projection to be like this and increase the offset a little bit, and let's add a flange to this nozzle. So from here, select the external projection of the flange, and from flanges we will add into flange. Okay, and from here let's select the suitable type for the flange. If you would like to make it from blade, there is another type of flanges which is designed flanges. You can select the suitable type for your case, but right now let's make it slip-on nozzle, slip-on flange, and define this. And from here let's click on save to add this flange to this nozzle, and let's update here simply. Now the location and the projection of the nozzle will be changed. After that, we will add the flange. Okay, like that. Now let's add another nozzle to this roof with internal deep projection, and after that we will add a nameplate here for this tank, and we will add the spiral stair. So if we select the can one, and from here let's add nameplate. And from here we will select the type of the name plate. Let's make it a vertical bracket like that, and define the bracket dimensions. So let's make it like that. Okay, and if you would like to add a client nameplate or ASME nameplate, you could add them and define the dimensions, but in our case we will not need that. Let's make it on 1 meter, and the orientation, let's make it on 0 degree, and the projection is 50 millimeters. And let's start this simply. Okay, sorry, we need to define the location of the nameplate. I think I make it 100 instead of 1 meter. So yes, it's 100. So let's make it 1 meter from the bottom, and click on start. Okay, now let's add the spiral stair for this storage tank. So let's select can one, and from here let's select the external connections, and from the external attachments you can figure that you have the ability to add many different types, like external enforcing pad, grounding like fireproofing clips, stiffening rings, nozzle support, ladder clips, insulation rings, platform supports, many different options. We will select the spiral stair, and from here we will start defining the spiral stair dimensions, like the clearance between this and the shell, the stair height. Let's make it 7 meters. The stringer width, let's make it like that. The contact angle, let's make it 85. The orientation, let's make it on 110 degrees. The height at a straight inch. Offset from base, let's make it offset from base with 20 millimeters. Inside width of the stair, here that's the direction, clockwise direction or counterclockwise direction. Step width, step thickness, step rise. Okay, and from here let's come down here, and the current shell thickness is 14 meters. the wear plate thickness, dimensions of the wear plate, the rail thickness, and from here let's select define the platform where the platform contact angle here, and let's define this to be 1 degree. On that side we will change the size of the rail post, so let's make it like that. The rail height, okay, rail bended end, to make a bend at the end here. Okay, thicknesses, so let's add some stiffeners here, here the second, third, fourth stiffener, so let's define the location of each one. Okay, and it's a closed platform, so the end of this platform will be, this platform includes the closed end. So we click save and start the assembly. The assembly of a spiral stair takes some time because it's include around 36 elements. So if we said each element takes 5 seconds or 4 seconds, so the spiral stair may take between let's say 1.5 minutes or 2 minutes. So let's wait for the assembly of the spiral stairs. During the assembly, any questions regarding the previous part? Hello?
Hello?
Any questions regarding the previous part?
Yeah, actually, we have some queries. Basically, what we have seen is this IS libraries, like IS material library is available in this?
You can define the material that you would like to define by that way. I will show you that. For example, here, if you would like to write the material by hand, like ST44, for example, you can do it like this, or you can get it from the material based on the ASME, select the table based on the ASME and search for your material like that. Okay. And you can get the grades available for this material, and you can select it like that by selecting.
Our question is whether Indian standards are inbuilt in this software, or we have to predefine those Indian standards.
As mentioned, those are the two ways available, by writing it by hand like this way, or get it from the ASME material database. Okay, those are the available ways to define the material.
Okay.
I hope my point is clear. Or you are asking for another?
No. Actually, Ahmed, what I was asking now, Indian standard material, IS material, is it available readily, or we have to define it like this way? Like ASME materials are available now. So he's asking,
yes,
just the
available only right now is the ASME material. The available is the ASME material. If you would like to give us this standard, and we could add it, no problem to us, but we don't include it yet on SEG. Just the ASME material, and if you would like to add the material by hand, you can define it like that way as I did.
There is no predefined material.
No predefined.
And second point is whether this normally we follow Indian standard code for design of storage tanks. In addition to that, we also refer API 650 also. So whether this Indian standard of code is inbuilt for this in this software?
No, sir. Actually, this is a modeling tool, and we can generate the different what we say deliverables like the GA drawings and BOQ out of it. But it do not have the analysis capability, sir.
No, not analysis. I'm not.
We are asking standards, sir.
Like welding details and manholes. In Indian standard, different type of manholes are there. In here we could see something else. So which is followed internationally. So is that or any other like we have to redefine that one also?
Ahmed is actually asking for the
It's based on API
yes.
620 and API 650. Those are the included standards for the storage tanks.
Okay, manholes, we have manhole dimensions with respect to API 650.
Okay, let's add a manhole after adding the spiral stair.
Okay.
After finishing, let's add a manhole and check how.
And every time we have to go for a new tank, a new modeling of new tank, or any other parametric modeling is there in this software. Like, can we make some changes to the existing tank so that we'll get the modeling of new tank? Like, if you are going to model second tank, in that case, I'm asking.
I don't get your point. Do you mean that if you would like to make editing for the dimensions on the same model, or make another tank by using that model?
By using that module, we can make another tank or not?
Yes, sure. You can make a save as from this project. Here on SEG, you can find that you can make a save as from this project and dealing with the new project by modifying the dimensions. Like, for example, you will define the redefine the annular blade dimensions, redefine those values, and regenerate the model again.
Sir, another one is on the roof tank. Roof plate, some agitator also is there, sir. Agitator plus rafter details means we put some channels on the roof also. Okay.
Regarding to the roof structure,
yes.
SEG not dealing with this point. We are dealing with the equipment itself, not the steel structure. So we make some simple steel structures for based on our customers' requirements. And I could show you something from that. Here, if we select this roof, and from elements, you can add a simple roof structure. We have two types of this simple roof structure. If we take a look to this structure, sorry. Here you can add this type of roof structure. It's a simple type by defining the required dimension. If you add a bracing, for example, add second UPN bracing. Let's keep those dimensions as they are, and just to define the inside diameter of the tank here. And let's keep this as a default value to show you this option for the roof structure. So let's come back to the Autodesk Inventor here. So we are dealing with the equipment itself, not the steel structure. The same for the platforms. You can add platforms on SEG, but not in detail. Here I mean the general arrangement of the platform, like location, the start angle, end angle, the rail height, all of that you can define it. But you will not get a bill of material for this platform because we generate it as a single part without any deep detail. For the I'm talking about the steel structure and the platforms. Okay.
Steel structure, sir.
But yes, still like roof structure here.
Roof structures.
But this roof structure, the roof structure that we create here, we make it on detail. But it's a simple shape, simple configuration. We make it in detail. But for the complicated configurations, we didn't make it. Okay, we generate that based on one of our customers' requirement. He asked us to make this simple structure because he usually deal with the small storage tanks, so maximum 12 meters inside diameter. So he said that we are usually using this type. So would you mind to generate this? Okay, so we generate it for him to be able to use it anytime. Okay, now if we take a section to the from here, for example, let's take a section like that. You can figure out that the steel structure for the roof. Okay, it's a simple shape, as I said. We created based on one of our customers' requirement. Now let's add a Manway to SEG. From here, let's open SEG, and from here, let's select CAN 1, and let's select API nozzle. So M1, let's add M1, and from here, let's select the type of this nozzle, if it's a from pipe or from blade. Okay, so let's make it from blade, for example. Let's make it 24. Those are the dimensions, and let's make it a low type. So make it diamond low type or circular low type. It's depends on your requirement, and let's make it 14. Here you can figure that the value of the low type should be with that value 630 or higher. That's the minimum value. So let's make it 150, and the orientation, let's make it 190 degrees. Define the projection, let's make it 150 right now, and let's click save. Let's add a flange. So from here, let's add the flange. So let's add M1 flange. And from here, let's select the API plate flange. It's 24. And from here, let's define the thickness to suit your calculation. Let's make it 20 millimeters. Click save. Now let's add a gasket into gasket. Okay, so let's select this, define the thickness of the gasket. Let's make it like that, and from here in M1, sorry, I add a gasket here to N2, sorry, so let's delete this. Sorry, I add a gasket to the nozzles on the roof. I should add it to the Manway. So from here, M1 gasket. So let's select the API thickness, add a blind flange, M1 blind. From here, let's select the API plate, find the thickness, and make it flipped. Click save, and now click start simply. Okay, here I define the flange size or flange type here. I defined it in a wrong way, so we will come back and redefine it again. So let's come back to the SEG. Here, after this nozzle, we define this one as a long weld neck flange. Sorry for that. So let's come back here and select the flange again, and from here let's select the API flange, define the thickness, and click save. Now let's update this flange. Here we have this clean outboard. Now, if we can figure that we have a clash or interference with the anchorage here, so we can rotate this Manway little bit. So if we come back to the Manway here, and let's change the orientation of this one like this, increase the projection a little bit. And let's add some attachments to this Manway, like add hand grip, M1 grip. Okay, so let's find this to be like that. So let's see orientation and click on save. Okay, now let's add a davit and bolts, stud bolts to this Manway. So if we come back here, and from here we will select the blind flange, and from elements let's add a Manway davit. You can select the suitable shape for your case. Here you can figure that you will have many different types and Manway hinge like this. So let's select this type of the Manway and define the outside diameter like that and click on save. Now let's add some stud bolts. Okay, if we come here and measure the thickness spacing, okay, so if we come back here and select set one, and click start to generate that. You can change the number of hand grips to make it 2 or any number by defining it from here. If we come back here to the hand grip, we can define it to be 2 hand grips. Okay, after creating the assembly, we will update this value. Okay, we will come back here and make this value 2 and run the assembly. Okay, we have those hand grips like this. Now we have this storage tank. I think we generated in less than 1 hour, and now let's proceed with the drawings. Before proceeding with the drawings here, if you would like to get the bill of material of this storage tank easily from here, you will have the bill of material of this storage tank. Here we have 522 elements in this model, and you will get the detailed description for plates, roof, bottom, and annular plates, shell plate courses, flanges, steel structure sections, all of that, bolts, nuts, all of that you will get it from SEG bill of material, including the weights of each element and the total weight of this storage tank. This storage tank, it's around 36 tons. Okay. You can get the nozzle table. Right now we have a sump nozzle and clean outdoor M1, M2, and here the service of each nozzle, the size of each nozzle, and other information like the connected flange, internal and external projection, all of that. If you have any fitting, it will appear here. We have one fitting which is elbow. Okay, and nozzle orientation table, flange table, gasket table. We have a one gasket for M1. Now let's proceed with the general arrangement drawing. From here we will start generating a new drawing, and from here we will select on create drawing. Let's select the drawing size to be A1, and from here let's select the elevation view. We will add one view only. Okay, here we have, if we take a look from the back view, for example, that will be the elevation view. Okay, so from here we will select the elevation view, and from here we will select the back view and make all the style of lines to be visible lines only. So the hidden lines will be removed. If you would like to show the hidden lines, you can select this checkbox. But in our case, we will make the visible line only appear. Define the location of the storage tank. Define the scale. Those values we will change them after creating the drawing to make them suits the drawing size and the scale. So from here we will select the bill of material, select the design data, select the nozzle table, and from here you can add some nodes. Some standard nodes you can delete or edit or add. So if you would like to delete, just select the node from here and edit it. If you would like to add a new node, you just add it like this or delete, or you can import it from Excel sheet. For the welding details, here we will take a look at this point. For the welding details, you will be able to select the required welding details for your drawing. In our case, for example, that's the circle or circumference longitudinal welding line, circumference here, and the longitudinal welding line style. If you would like to make this welding as a flip welding, so that means is the welding will be from this bevel will be from inside or the outside, so you can select between them. The flange connection, and here the elbow weld. Okay, we have a nozzle with rebad, and we have a nozzle with internal projection with rebads. So if we come here, we have a nozzle with internal projection with rebad. Okay, and for other detail like the nameplate or other attachment clips, the clean outdoor flange weld detail. Here you will find some other standard details for the sketch plate detail, for example, the overlap and the detail like that for the bottom, roof, and shell. So you can select the suitable detail for here for the annular plate detail with the sketch plate or the bottom plates. For example, you can select something like that and click on save. Now from the title block, we will generate our drawing. Document number. And let's define the vision table. Let's click save. Let's add some empty rows here. And from design data, as you configure in this model, we have a large bill of material. No space will be available on the drawing, so we can separate it on another sheet on the same drawing. So we will have a sheet 1 of 2 and sheet 2 of 2. So in this case, we will make this sheet from this drawing from 2 sheets, and the second sheet size will be A3 drawing. And from here we will separate the bill of material to make it on sheet 2. And let's click on save. Now let's generate the drawing of this storage tank. Here's that the bill of material sheet. As you configure the bill of material list filled automatically, and it will updated and takes place will be added to the over the vision table location, and you can modify the location of the bill of material and the style of the bill of material, and we will check that after exporting the data. Now we have the general arrangement drawing with sheet 1 of 2. Here we have the design data, the notes, the nozzle table. Now the welding details will come to the drawing. Okay, now we have the welding details to our drawing, and now let's make a modification for this view, increase the size. So we will change the scale and the location of this one. So from here, let's come back to the drawing, and from here, let's make the scale of that one like this, change the location, and let's test that. Okay, now if we would like to make a top view for that one, we can make it easily like that, and we can break the link between them and move it on the suitable place. for our case. So that's the top view. So we can move this view a little bit here. So from drawing and change this location and that one. Click on create. Okay, now let's add some dimensions. Here let's select the center line, add some of that. Those are the anchor chairs holes. So if you would like to make the bolt circle diameter in this view, you can do it. And I will show you how to add some details to this drawing. And if you get a chance to check our videos on our YouTube channel, you will know more about making drawings and how you can modify and edit in your drawings. Here, let's add a balloon for this nozzle, like add the nozzle tag. Nozzle N2. Here we would like to add the start angle of this one, the spacing between the anchor chairs, like this. For example, if you would like to measure the blade length from here, but we could separate it because we need to make a flat pattern for this roof, and let's proceed with this to make the flat pattern with the roof. So let's add some dimensions to this one. Let's add a center line for the tank. N1, and if you would like to define the reference point to define the location of nozzles, so that's the reference point, and from here that's the location of this nozzle, and let's add a center line to this one. So the nozzle type. And let's hide this. So let's hide the origin point from here. Okay, now we have a detailed drawing, and we could add more details more than that. But right now, let's get the roof plate arrangement. From here, let's open the updated plates for this one. And from here, let's create the flat pattern for this roof. As you can figure, this conical shape, to create it, actually in fabrication, we create the actual dimensions of the circle, which includes the tilted line here, or this sloped line length as the radius of the circle. After that, make the arrangement of plates. After making that, we make a slice cut and to get the conical shape. Okay, so from here, let's create the flat pattern. If we take a look from the side view for this simply, okay, after finishing, let's take a look to the side view. Here, that's the slice cut calculation. Okay, if we take a look, you can figure that it's a straight plate, not a conical plate like this case. Okay, so the dimension here are real. If we would like to make a plate drawing for this here, that's the slice cut, which is the value that we need to cut before making the conical shape. So if you would like to split it to different pieces, for example, if you would like to make it 2 pieces, for example, so the slice will be divided, or if you would like, for larger tanks, for example, if you would like to divide it, you can make it like this. So you have an option to make changes the slice cut number. Okay, right now we would like to generate a drawing for this. So from here, let's generate a drawing for those plates, and from here let's select A2, and let's select the view to be the front view. Okay, so we will add a variant, so it will be the front view. Let's make it 36 degrees. Define the location. Right now, the location. Okay, 25. Okay, let's add some weld details for that. So remove all nozzles. All that we need, which is the overlap detail for the roof plates, which is that one. Okay, and that one, and click on save. Okay, and from here let's add roof plates. Click add. Let's add some empty rows. Here, let's make it one sheet, and let's create this drawing. We come back to SEG here. We have this drawing like this, includes those welding details. So let's move them like that. And now if you would like to make a detail for each blade from here, for example, let's open this one and come back here to add a detail for this plate. Make the scale 1 to 20, 30 for example, and let's add it like this. And from here you can measure the dimensions of this plate, and like that. Let's add the second blade, for example. Let's open this one. Let's move this view right here, and let's arrange those plates. So you can get the dimensions of each plate by that way. Another plate. The actual lengths for plates to be cutted like that, and that's the slice cut, which should be cut before making the conical shape. Okay, any questions during the regarding the above the discussed points here?
Shell plate fabrication. Yes, shell plate fabrication drawings how to generate. This is a GA drawing we have generated, and roof plate part drawing we have started, right? in how to generate shell plate drawings, fabrication drawings.
What do you mean by shell plate drawings?
Part drawings.
Okay, there is an option in SEG. I hope that I get your point. Here in SEG, we have shell development tool. In this shell development, you can figure that we can get the shell development for plates. And from here, if we click on the flat pattern, we can generate the assembly of the flat pattern of plates. I'm talking about if you get a chance to watch some of our videos, other videos, because this session we cannot cover all points in one session. So if you get a chance to watch some videos to know how to generate the drawings and the detailed drawings for elements, how to make a detail for a support or how to make a detail for a nozzle, you will find a lot of videos related to this point. Because I will not be able to cover all information in one session.
स्क्रीन शेयर कर सकते हैं?
वहाँ पे जाइए। थोड़ा सा इसको ये कीजिए, गैलरी डिवाइस रिक्वेस्ट कंट्रोल नहीं है हमारे पास, शेयर नहीं हो सकता है ना? हाँ शेयर।
Here, if we take a look to the shell flat pattern, here you can find that the degree orientation 0 degree, 90 degree. So if we make a drawing for that, if we come back here, that's the front view. So if we come back here and generate a drawing for this, make it A2, so make it from front view. 30 degrees, 25. 70 for example, maybe 100. Remove all of that. Will not need that. Okay, 3. I should also think here. If we edit the size, let's make it into, and let's add the view for this one. Okay, that's the shell development for the plates, and if you would like to add the pieces, let's define the change the style of the dimensions. Is that your point, which you was asking about, or
Yes. So in this drawing wise bill of material, can we put in the drawing?
Yes. Okay, if we measure the length of each plate like this, if you would like to add the plate lenses like that, as we defined, you can figure that the length of each plate as we defined on the bill of material. So that's the first shell course. If we come back to SEG, let's close this and come back to SEG. Here from that's the first can. If you take a look to the blade lenses, here we have those plate lenses, okay, the same as we will get on the drawing right here. The same for the second course. Here back to the second course, the same dimension of the blades that we can get the drawing. If we come back to again to the general arrangement drawing, you can figure that that's a bill of material. Let's update the arrangement of this one. Let's make it start from top to bottom. Let's make this the width of this one a little bit bigger, and let's move it down here.
ड्राइंग में नहीं आता
ड्राइंग में वो हमारा आधा क्वेश्चन तो
So let's split this bill of material at 7. So let's make a work table. Now we have this complete bill of material for the equipment.
Sir, sir, this is complete BM for our total tank, yes?
Again, please.
What you have shown, that is complete bill of material for the complete one tank.
Yes, the complete bill of material for the tank.
But what actually we issue bottom plate drawing separately, top plate drawing, roof plate drawing separately.
You can do that. You can do that. Okay.
Which can give separate BM for
okay. As I told you, if you get a chance to check the our videos, you can figure that easily. For example, okay. let's make a detail for the anchor chair. Okay, so from the drawing here, let's create a drawing for the anchor chair. Click A3 and the elevation view. Let's open the anchor chair. Here we have that one. So let's open the anchor chair. So we will make the elevation view as a left view. After that, we will modify it. So we will make it as the left view. So let's select this one to be here set as front view. Okay, so from here we will select front, but let's save that first. Okay, so let's come back here. Let's select the front view, make the scale 1:6, for example. Let's add the bill of material. You can add a weld detail, but you're asking for the bill of material for this one. Let's select the bill of material table for this anchor chair, and let's create the drawing. So from here we will have this anchor chair, and here that's the bill of material of this one, which includes the item number. Now we can change the size, the scale of this one and location by changing that one to make it 10, make it 15, change the scale to be 2, and let's add another side view. Okay, make it like that and make this spacing, create drawing. Okay, so you can figure that. So let's minimize the scale. Okay, so from drawing, let's minimize the scale a little bit, remove this, and let's create a drawing. Here, if you would like to add another view like that, or 3D view, this one. You can add weld details. Okay, many other things you can do by sending the data to Autodesk Inventor and generate the your 2D drawings like that. Okay, so by the same way you can get the bill of material to your drawing. Here for the roof plates, from the updated plates, we generate the drawing. If we open the drawing again, you will be able to add a bill of material. So let's update the bill of material and let's save this and let's generate the drawing. And here the bill of material of the roof plates will be generated. Let's move it a little bit up here, like that, and change the location of the roof plate. Okay, one more point, let's say it, to get the item number here, to reflect it on the elements, because if we select the balloon item number and select this item, for example, okay, you will find that the balloon is empty. To reflect this value, we should come back to SEG and click on the update item number. Okay, this button will reflect the item number to each item here on the bill of material. Because if you would like to know what is this element, which element, so you can get the number of this one regarding to this one. This step may take between 5 or 10 minutes for those items. So if you would like to wait up until updating this item, or you can review our videos regarding to this point. So SEG collect the identical items and give them the same item number. For example, we have 8 plates here with the same dimensions. So SEG will give them the same item number. To reflect this item number to the drawing, we should click on update item number button from here. Okay. Any questions regarding to this session?
Actually, we have this roof.
I should engage another meeting.
Will not make much of your time.
But if you have any questions, we can discuss it in the next 10 minutes.
Only 1 minute. We'll take one minute of you.
Okay.
Actually, this structure, whatever you have shown in the roof, that is on the external side of the tank for our application.
Okay, so it's okay. No, it's okay because it's out of your scope.
If we show our drawing, can we customize those components in the software?
Yes, yes. As mentioned, if you have some elements, or if you would like to include a spec for something that usually used from your side, you can send it to us, and our development team will add it to SEG library to be able to use it anytime that you would like to use.
So one thing we'll do, we'll send our one of the tank already modeled in 2D. We'll send that drawing to you. Just have a look and please suggest come back with the solution. Okay.
So what do you mean? After receiving your drawings?
Yeah. Please go through that drawing.
What? You asking me what?
Yeah. Please go through that drawing. Like whether we can implement implement any inbuilt components in the software, or can we develop in the software? Please look and come back.
Inshallah. Waiting for your drawings, inshallah.
Yes. Huh?
Yeah. But as you can figure, in 2 hours we generate a storage tank. It's simple, but it still takes a huge time in a traditional way. And we generate the drawings, including the bill of material. And if we take more 2 hours, we could generate all drawings for hold the tank. So actually, we may take between 4 or 5 hours to generate a tank like this and detailed drawings for this one, after adding some other nozzles. But in the traditional way, I think it may take 4 or 5 days, maybe more than that.
Okay.
Thank you for your valuable time. And I hope that we can cover some of your questions in this session.
Yeah. Thank you very much. You have gave a clear picture to us what actually SEG does and what all components can be made as per our requirement, and mainly with respect to bill of material and the drawing generation activities which can be done with respect to this storage tank. Thank you very much, Ahmed.
Have a nice day.
Yeah, thank you.
Bye.
Thank you, sir. Yeah, thank you, Ahmed.
Thank you so much. Have a nice day.
Yeah, thank you.